theme is the astrophysics and space science, and this actually brings together a huge number of disciplines of people who are doing astrophysics, from stellar physics to cosmology to things like gravitational waves and also solar physics. Depending on what the students are doing, students who are working on an observational project, they have very good courses about data analysis and observations, which are happening in the semester 1 and in semester 2. Students who are not working on an observational project, they may be also still interested in doing the data analysis course. And then there are also some other more specific courses like the gravitational wave detection that may be also relevant for students who are involved in gravitational waves or cosmology. There are tons of advances happening all over the place because we had the launch of the James Webb Telescope less than a year ago. There are also many ongoing missions like TESS and Gaia measuring the universe. Also, if we go to this kind of time resolve data, we will have soon the Vera Rubin Observatory, and we have also the Zwicky Transient Facility that is already operating. So there are lots of data coming for the observational community. We also have the gravitational wave community doing impressive work. And all this is also triggering a lot of advances in theory. And then the other very interesting thing that is happening now is that there are a lot of public observing programs and community effort to tackle different problems. So this involves some large facilities like the Hubble Telescope or ESO facilities. So there is really a huge amount of things happening right now, and they are going to be even increasing in the coming years. So it's a very, very interesting time for any field in astronomy and space science. There is also a huge number of roles that students tend to take, because when you're doing a PhD in astronomy, you're gaining like a very good set of skills, like problem solving, like figuring out what is up from a collection of data, observational or a vast amount of information. Also things like programming, students tend to be very strong, image analysis, data analysis, large data analysis. So then we have students who are able to move in many different directions. So in addition to the kind of classical research and teaching in high education level, we also have people who move into all sort of careers that have to do with data analysis, from working for things like the NHS to big data companies. We also have people who going to working with finance, for instance, and also any other company that may need to deal with a risk assessment and consulting. We also have people who go into working with companies, especially if they have been more related to observations or instrumentation. They may work in companies that deal with similar things. I mean, even space telescopes are also very often made in companies, like even Herschel and James Webb, right? So there is also an option to move in that direction. Imaging is also a huge field. So, and this ranges from kind of analysis of various kinds of images, maybe from the Earth, but also from the body, identifying structures and patterns, satellite technology. And then, of course, there are also people who go into careers with teaching at the high school level, and also outreach. So once that you learn about astronomy, that's also you just mention it and everyone wants to ask you things about, right? So there are also many people who decide that they really like this contact with other people and promoting the interest in science, and they go into an outreach career. One important thing about research nowadays is that you are never working in isolation. So there is always like a community effort. So I would encourage students to get integrated within a larger community, whatever their field of work is, and try to be part of that community, because nowadays is a time of space telescopes and large facilities, huge computing efforts. So this is something that you can't really do alone. So try to get into an international community of researchers and try to work together with many different people, because you will also learn a lot. And then even if your idea is not to stay in science, you may also then want to get in contact with the relevant community for what you want to do, get in touch with what could be interesting for industry, get in touch with what would be interesting for outreach or teaching. So I think it's very important to become part of a community, because you are never going to be working in isolation.